Now that we've spent some time talking about number of moles of things, like number of moles of molecules, electrons, particles, etc., we've also spent some time talking about molar mass. Let's go ahead and pull these together for some common questions. First up, an aluminum sphere contains 8.55 times 10 to the 22nd aluminum atoms. What is the radius of the sphere in centimeters? The density of aluminum is 2.70 grams per centimeter cubed. Well, I know that volume is equal to 4/3 pi r cubed. I see the r right here for the radius, right? So I must be looking for volume here because I got to undo it to find the radius. So I'm going to be looking for that volume of the aluminum. I'm going to start with the measurements I have, and I have 8.55 times 10 to the 22nd aluminum atoms. I'm going to have to use the density at some point, but the density is in grams per centimeter cubed, so that conversion does not help me right now. But I do have number of atoms. I mean, looking at number of atoms, what conversions do I have? I know that 1 mole of things equals 6.022 times 10 to the 23rd of those things. That could get me into moles, so let's try it. 1 mole of alumina to 6.022, 10 to the 23rd aluminum atoms. So at this step, I have canceled out my number of aluminum atoms and I'm into moles of aluminum. Moles isn't going to help me though. I need to get to volume. I've got the density, and the density can help me get to volume. It can help me get to centimeters cubed, but the density must be in grams to do that. So I've got moles. I know that the molar mass, though, can convert between grams and moles. So I look up at the periodic table, and I see that it takes 26.98 grams of aluminum to equal out to 1 mole of aluminum. Again, that is atoms of aluminum. Now I'm in grams of aluminum. Now I can go ahead and use the density as a conversion factor to find the centimeters cubed of aluminum, which is the volume of aluminum. So this tells me that for every 1 centimeter cubed, it weighs 2.70 grams. And that is for aluminum specifically. That cancels out my grams of aluminum and gets me to centimeters cubed of aluminum. So I see here I have 1.42 centimeters cubed for the aluminum. Now I can go ahead and undo that volume. To undo that, to get R by itself, I'm going to take the volume. I'm going to multiply it by 3 and divide it by 4. Because again, I'm going to multiply both sides by 3 and divide both sides by 4. That's what I'm doing here. Okay, so V equals 4/3 pi r cubed. First thing I do is multiply both sides by 3. That cancels my 3's here. Next thing I do is divide both sides by 4. That cancels my 4's here, okay? Now I've got pi r cubed. I need to divide both sides by pi. That cancels my pi's. I've got 3v over 4 pi equals to RT. Take the cubed root here, and I'll just have r on the other side. So my r is equal 3 times the volume over 4 pi, and I'm going to take the cubed root of that. So plug in what I know. I know it's 3 times 1.42 centimeters cubed divided by 4 pi, and I'm taking the cubed root. Some of your calculators have a cubed root. It usually looks like a button like this, okay? If you don't see that or you're unsure how to do a cubed root on your calculator, the other way to do it is to take that whole quantity, put it, like either calculate it out or put it in parentheses, but what I mean is take this quantity, 3 times 1.42 divided by 4 times pi, take that whole quantity and raise it to the 1/3 power. That will do the same thing as taking the square or the cubed root. Take the cubed root of this, and I get out 0.697. And then the centimeters, because I took the cube root of the centimeters, it also brings that down to just straight centimeters. Sig figs, I had 3, 4, and 4. So my final answer has 3 sig figs. Let's look at the next one. How many water molecules are there in 675 grams of water? I'm going to move this up just so I can read on the screen. First thing you need to do is the molar mass of water. I know I have 2 hydrogens and 1 oxygen. When I add this all up, I get 18.02 grams per mole for water. What I want to know is how many water molecules I have. And I'm starting off with 675 grams of water. First thing I have to do is convert to moles. 1 mole of water weighs 18.02 grams. We just figured that out with the molar mass, right? Grams to grams, the moles are canceled, or the grams have canceled, now I'm in moles. But I don't want moles, I want number of molecules. That is Avogadro's number. So times 6.022 times 10 to the 23rd. Water molecules contained in 1 mole of water molecules. Let me move this over so I can fit it on the screen. When I calculate this out in my calculator, I'm getting 2.26 times 10 to the 25th water molecules. Again, make sure you're practicing these in your calculator because I need you to make sure that you know how to get the right answer, okay? Sometimes calculators get a little funky, especially with scientific notations. I need to know you know what you're doing. Okay, what's up next? How many moles of carbon are in 25 grams of carbon? Okay, this is one of the examples that's actually kind of easy to like self-check yourself. Not all of them are. Some of them, the numbers are just really big or really small. This one's actually not that hard to self-check. What I mean by that is that what I'm trying to find, okay, let's say I'm trying to find number of moles of carbon. And I'm starting off with 25 grams of carbon. When I look at the periodic table, I see that 1 mole of carbon weighs 12.01 grams. So when I calculate this out, I get 2.08 moles of carbon. This is one of those examples that I can kind of self-check myself on because I know that 1 mole weighs 12 grams and 2 moles weighs 24 grams and I have 25. So I should have just over 2 moles of carbon, and I do. Again, not all examples are easy to self-check like that. The next example is an example that I can't self-check. The numbers don't make sense to me. I have to trust myself, and I've done enough practice problems that I know how to use my calculator. So how many iron atoms are in 675 grams of iron? Oops, number of iron atoms. I have 675 grams of iron. You always have to convert through moles, okay? I don't care what you're doing. If you don't know what to do, convert to moles. It's probably the right step. 1 mole of iron is 55.85 grams of iron according to the periodic table. I apologize, I have kittens, if you can hear them. And usually I wear an earbud to help cut down the noise, but I definitely forgot it in the other room. So now I've converted to moles of iron. Now I can go ahead and convert to number of iron atoms. 6.022. 10 to the 23rd iron atoms over 1 mole of iron. This cancels out my moles of iron. It gives me a number of iron atoms, which is my goal. I calculate this out, and I end with 7.28 times 10 to the 24th iron atoms. So again, this isn't a number that I can just like self-check and say, yeah, that totally makes sense to me. I mean, I know that I have more than a mole of iron, so I expect the number to be bigger than 6.022 times 10 to the 23rd. But truthfully, the number is just so big at this point that I can't really correlate that well. I just, again, have to trust myself that I know how to use my calculator. Okay. So the mole concept provides multiple ratios. There's two places to get these multiple ratios. We can get them from the subscripts of the chemical formulas or from the coefficients of balanced equations. So what I mean by that is when I look at this when I look at this formula here, the magnesium nitrate, this is telling me that I have 1 mole of magnesium ions for every 1 mole of magnesium nitrate. I could say I have 2 moles of nitrate for every 1 mole. I apologize, she's got her mouse, her toy mouse, and she is quite happy about it, and she's destroying things right now. 1 mole of magnesium nitrate. I could even say I have 3 moles of ions for every 1 mole magnesium nitrate. The 3 moles of ions being 1 magnesium 2 plus and 2 nitrates. I don't always have to compare them back to the original either. I could say 1 mole Mg2 plus to 2 moles, Siri's driving me nuts, 2 moles of nitrate. These are all different conversion factors. But I can also get these from the balanced chemical formula or balanced equation, whichever way you want to call it. So here I can say 2 moles C2H6 react with 7 moles of O2. I can say 7 moles of O2 for every 4 moles of CO2. I could say 6 moles of H2O for every 2 moles C2H6. I can do anything in the numerator or the denominator from the chemical formula or from the balanced equation itself because they're all giving me mole ratios. So let's go ahead and do some examples with that. First up, how many hydrogen atoms are there in 59.3 grams of water? So I'm trying to find number of hydrogen atoms. And I'm starting off with 59.3 grams of water. Again, if I add up the molar mass of water, 2 hydrogens, 2 times 1.008 grams per mole, 1 oxygen, 1 times 16.00 grams per mole, overall 18.02 grams per mole. So I've got 59.3 grams of water. And the first thing I'm going to do is convert to moles. 1 mole of H2O is 18.02 grams of H2O. Now that I've got moles of water, I can convert to moles of hydrogen because the formula gives me the ratio, the mole ratio I need. I see that I have 2 moles of hydrogen for every 1 mole of water. Now I have moles of hydrogen, and now I can use Avogadro's number because I know that for every 1 mole of something, I have 6.022 times 10 to the 23rd of that thing. Just double check yourself. Your grams of water have canceled. Your moles of water have canceled. Your moles of hydrogen have canceled, and you're left with your hydrogen atoms. When you calculate this out, you get 3.96 times 10 to the 24 hydrogen atoms. And the next example, how many nitrite ions are there in 3.99 grams of aluminum nitrate, AlNO33? So you add up the molar mass. First thing you do is you add up the molar mass, okay? So 1 aluminum, 26.98 grams per mole. 3 nitrogen, again that 3 correlates to all of this, so 3 nitrogen, 3 times 14.01 grams per mole, and 3 times 3 here, 9 oxygen, 9 times 16 grams per mole, Add all of that up, and you're going to get 213.0, need that for the sig figs there, grams per mole. What are we trying to find? Number of nitrate ions. Starting off with 3.99 grams of the aluminum nitrate. First thing I need to do is convert that to moles. Because again, moles is a number word. Moles is telling me how many of something I have. Moles is taking the mass out of the equation because every atom weighs something different if it's not the same species with the same isotope even, okay? So oxygen atom doesn't weigh the same as a nitrogen atom, doesn't weigh the same as aluminum. By putting it into moles, you have taken away all of the differences between them and normalized them all to the same number of species. 1 mole of aluminum nitrate weighs 213.0 grams. So I've canceled out my grams of aluminum nitrate. Now I'm in moles of aluminum nitrate. But I don't want moles of aluminum nitrate. I want moles of nitrate. I see that there's 3 moles of my nitrate ions for every 1 mole of aluminum nitrate. That cancels out my moles of aluminum nitrate and gives me the moles of nitrate. Now I'm definitely going to run out of room here, so let me shrink some stuff. Now that I'm in moles of aluminum or in moles of nitrate specifically, I can use Avogadro's number. 6.022 times 10 to the 23rd. Nitrate ions are contained in 1 mole of nitrate. That cancels out my moles of nitrate ions and gives me just nitrate ions themselves. When I calculate this through, I get 3.38 times 10 to the 22nd nitrate ions. Again, that's not one that I can just like question myself and be like, yeah, that makes sense. I'm going to have to just trust myself. I know how to use my calculator at that point because that number, I mean, I know it'll be less than a mole, but the number is so big it doesn't really correlate well in my brain. Let's do a few more. How many ions are in 15 grams of ammonium carbonate, NH42CO3? So this one is asking how many ions. It's not specifying which one. So I have to think about what ions I have present. I have 2 ammonia ions. So 2 of my ammoniums and then 1 carbonate ion. There's 3 ions for every 1 mole of ammonium carbonate. So how many ions? Well, I've got 15 grams of ammonium carbonate. First thing you do is convert to moles. I need the molar mass to do that. When I add up the molar mass, I have 2 nitrogens, I have 8 hydrogens, 1 carbon, and 3 oxygens. So check yourself, but you should get 96.09 grams per 1 mole for the molar mass. At this step, I have got rid of my grams of ammonium nitrate and my moles of ammonium nitrate. Now I can convert to the moles I want, which is moles of ions. I have 3 moles of ions for every 1 mole of ammonium carbonate. So that cancels out my moles of ammonium carbonate. Now I've got moles of ions, and so now I can go to number of ions. So Avogadro's number times 6.022, 10 to the 23rd ions per every 1 mole of ions. This gives me 2.82 times 10 to the 23rd ions. Okay, we've got 2 more examples in this module. Let's see, how many moles of calcium ions do you have if you have 3.00 times 10 to the 21st formula units of calcium nitrate, CaNO32? Formula unit means it's what we use for ionic compounds when it's not a molecule. Because remember, calcium nitrate it's not really one calcium ion floating around with 2 nitrate ions associated with it. It's really building up a large lattice structure. And so we use formula unit when we have an ionic compound to account for the fact that it's actually a 3D array of that structure, not just simply one molecule. So write down what you're trying to find. Number of moles. Calcium nitrate. I'm starting with 3.00, 10 to the 21st formula units of calcium nitrate. Convert that to moles. 1 mole of calcium nitrate. Let's see. I've got that, so Avogadro's number is 6.022, 10 to the 23rd formula units of calcium nitrate. Now I'm in moles. Sorry, this slide works great when it's on the screen and I'm writing on the board. It's not so great when I'm writing on the computer or writing on my iPad. Okay, this cancels out my formula units of calcium nitrate. Now I'm in moles of calcium nitrate. Is that all I need? I want moles of calcium. I apologize. It's late here. It's dark. I have my front window open and some car was just sitting there at the street that my house dead ends into with their lights shining right in my face. And it was kind of weird. And it was incredibly distracting. 1 mole of calcium ions. Calcium is a 2+ charge. It's one of your alkaline earth metals. Always a +2 charge. Plus I know nitrate, my polyatomic, is always a -1. 2 of them equal out to a calcium being a +2 charge if I forget. 1 mole of calcium ions for every 1 mole of calcium nitrate. Cancel out my moles of calcium nitrate, and now I'm in moles of just calcium ions. I calculate this out, and I get 0.00498 moles of calcium 2+. So again, one of those examples where I can't really say oh yeah, this number is perfectly good. I trust myself, but I do know that it should be less than 1 mole because I have less than 1 mole of the formula units of calcium to start. And the calcium formula unit is a 1-to-1 ratio to its formula. There's 1 calcium ion for every 1 formula unit of calcium nitrate. Okay, and our last example for this, our last example for this section. A cereal contains 11.2 grams of sucrose, C12H22O11, per 60 grams of cereal. What mass in grams of cereal must be eaten to consume a total of 0.0424 moles of sucrose? Let's find out. I'm trying to find number of grams of cereal. Got a few things going on here. I've got 11.2 grams C12H22O11 per 60 grams of cereal. Let's see, I wanted a number of massive grams of cereal. I got that. And I've got a total of 0.0424 moles C12H22O11. Truthfully, you can start with whatever you like. I like starting with a number that's by itself, not a conversion. You could start with the 11.2 grams of sucrose to 60 grams of cereal. I don't care. But I'm going to start with 0.0424 moles of the sucrose because I just like starting with numbers that are by themselves. 0.0424 moles C12H22O11. Now, the conversion I have here is grams over grams. This is moles, so clearly I can't use that conversion yet. So let's go ahead and convert this to grams. 1 mole C12H22O11 weighs 342.3 grams of C12H22O11. Again, I got that by 12 carbons is 12 times 12.01 grams per mole. 22 hydrogens, 22 times 1.008 grams per mole. And 11 oxygens, 11 times 16.00 grams per mole. And then summing that up. So this step right here got rid of my moles of sucrose and into grams of sucrose. Now I can use that conversion, but be careful how you write that conversion. You got to think about what you need here. What we want, sorry, I'm trying to shrink that. What we want is number of grams of cereal. What I'm trying to cancel out is number of grams of sucrose. So I need my grams of sucrose in my denominator. So it cancels out. I need my grams of cereal in my numerator because that's my goal. That's what I'm trying to get to. So I'm going to have to flip this over. 60.0 grams to 11.2 grams of sucrose. That cancels out my grams of sucrose. That results in my grams of cereal that I'm trying to get to. I calculate this out. 3 sig figs, 4 sig figs, 3 sig figs, 3 sig figs. Final answer will just have 3 sig figs. 77.8 grams of cereal.